Here we want to prove that segment TB is congruent to segment HE, given TY was congruent to YH, and angle 1 is congruent to angle 2. We've got triangles over here, so the route we probably want to take is proving those two triangles congruent. So I'll go ahead and write TY congruent to YH, angle 1 outside the triangle is congruent to angle 2, which is also outside the triangles. So that might be a problem. But looking at our picture, we should know that angle there and that angle there are congruent to one another because they're vertical angles. So I'll go ahead and write angle BYT is congruent to angle EYH because vertical angles are always congruent. Okay. And we jumped right into that, looking at our picture and finding what our picture was hiding, mainly because there was nothing in the given. There were no vocabulary words in the given. Okay. If there were vocabulary words, that would probably have been the first thing we did, is look at those. Next thing I got to do is look at these angles 1 and 2. It would be nice to know that that angle there is congruent to that angle there. Then I'd have angle side angle inside my triangles. However, we know that the angles on the outside are congruent. So let's see what we know or what we can show about those angles on the outside that would lead us to something about the angles on the inside. If I looked at angle 1 in this angle right here, okay, you notice that those two angles form a straight angle or a straight line. So the angle addition postulate says those two angles should add up to 180 degrees. So I'll take angle 1 and add to it, and it should be the measure of angle 1, and add to it the measure of angle BTY, and set that equal to 180 degrees. That's your angle addition postulate. Hopefully we've seen enough of these in class that we're going to realize that once I say a statement like this, I'm probably going to want to try to find another statement that looks very similar to it, okay, where I add two things together and set them equal to 180. Well, if we look over here, we can take these two angles, because they form this straight angle, and add them up and set them equal to 180. So I'll say measure of angle 2 plus the measure of angle EHY is equal to 180. Okay, so here's the pattern that we see all the time, or see frequently. I have two things set equal to 180 and another two things equal to 180. I want to take that and set it equal to that. So I'll say measure of angle 1 plus the measure of angle BTY is equal to the measure of angle 2 plus the measure of angle EHY. And I can do that because they're both equal to 180. So let's set them equal to each other. That's either the transitive property or substitution. I'll accept either. Okay, the pattern continues here. Once we have two things on the left-hand side equal to two things on the right-hand side, we usually want to look and see what can we remove from the left that we can also remove from the right. Most of the time, it's not going to be blatant that you're going to see the same symbols on the left as you see on the right. Okay, angle 1 shows up on the left, but nowhere does it show up on the right. Angle BTY shows up on the left, but nowhere on the right. Okay, remember, these are values. So we're looking for values that show up on both sides. They're representing values. If we remember that angle 1 was congruent to angle 2, that told us that measure of angle 1 is also equal to the measure of angle 2. Okay, we can say that because of our definition of congruency. And we want to change these to equality, measurements being equal. We want to change that because we want to do some subtraction here. And I can only subtract values from values. If I didn't change it from an angle congruency, I'd be taking a measurement and subtracting an actual figure, and you can't do that. Okay, so it's got to be value minus value. Just remember, if you're ever going to subtract something out of a statement, you want to make sure that you're always subtracting either distance from distance, angle measurement from angle measurement, never a segment from distance or distance from a segment, or an angle measurement from an angle or an angle from an angle measurement. Okay, you always want to be consistent. So now that I've recognized that those two things are on the same side, I can actually get rid of them. And if I got rid of them, I'd be left with measure of angle BTY equal to measure of angle EHY. Okay? Now, what allows us to basically remove the same thing from both sides is simple subtraction. Okay, and that's a property of equality. Okay, because you did the same thing to both sides. Once I say that, I'm going to jump back from values, and now I want to talk about the actual shapes, the figures. So I'll say angle BTY is congruent to angle EHY, and that's just your definition of congruency. That allows me to come back up here to my picture. Angle BTY is this angle here, angle EHY is this angle here. Now I know that those two things are congruent. So now you recognize you got angle side angle in this picture, or this triangle, angle side angle in this triangle. So I'm going to say triangle BTY is congruent to triangle. If I started at B and went to T to Y, I got to start at E, H, and then go to Y. So EHY by angle side angle. And now that I know I have two congruent triangles, I can say that any parts of those that are corresponding are going to also be congruent. So they wanted to say T and B. So those are your first two segment or first two corresponding parts, and E and H. Okay, so BT corresponds to EH, so you can go ahead and say BT is congruent to EH, and your reason is CPCTC. So we've proven, and now it's backwards again, but that's okay because any segment, if I call it TB, I can always call it BT. It doesn't matter, left to right, right to left. Same thing with EH and HE. Okay, so now we know we're done.